All right, so again, remember when you're graphing these in standard form, it is pretty straightforward because the graphing form does have your vertex in it. So remember, this should shift it right 3 and up 2, and that would be our new vertex right there. And then we want to create our parent graph table to get the other points. So remember, our parent graph table is just y equals x squared. So if I square every number from -2 to 2, it'll give us our movements from the new vertex. So -2 squared, remember, is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So now this is like my new 0, 0, the new vertex. So I'm going to go left 1 and up 1 from that new vertex. The mirror image would be right 1 and up 1 from that vertex. And then I can go left 2 and up 4 from my new vertex. And then I can go right 2 and up 4 from my new vertex. Now, since we have it graphed, and it says state the x and y intercepts, will we have any x intercepts? No, so we don't have to show work for that if we have it graphed. And we can just say no x intercepts. Now, we do not see where it crosses the y-axis, so we do want to solve for that. Remember, to find the y-intercept, you're plugging 0 in for the x's. So I'm going to find f of 0. And so when I do that, 0 minus 3 is -3. -3 squared is 9. And so 9 plus 2 would be 11. So the y-intercept would be 0, comma 11. All right, so that's what we did yesterday. Today, what we're going to look at is if you have an equation in standard form, how is that going to, or how would we be able to graph that in standard form? So to do that, we're going to, you can title this, maybe. All right, you can graph it, or title it Graphing Parabolas in Standard Form. And standard form is y equals ax squared plus bx plus c. Okay, so the first thing you want to do is you want to figure out how does it open. Okay, so remember, a positive a value opens up, a negative a value opens down. Then you want to find your x-intercepts. Remember, that's where we set y equal to 0 or the f of x equal to 0. You will need to factor because these are all going to be quadratics. Okay, so just making a little note that you're going to need to factor for those. Then we want to find our vertex. So once we have our x-intercepts, we can find our vertex. All right, so the way we find our vertex is there's two ways. One way we can do it is by averaging the x-intercepts because our vertex is always going to go right in the middle of the x-intercepts. So we can take the average of the x-intercepts, and then we'd have to take the f of the average of the x-intercepts. So the average of the x-intercepts just gives us like our h value. Then we have to plug that value in to get the k value out. The other way you can do it is you can if you're good at memorizing things, the other way you can do it is negative b over 2a. So if you look at the standard form equation, the b is what's in front of the x, so you take negative of whatever's in front of the x and divide it by 2 times whatever's in front of the x squared. And then you'd have to also find the y value for that, so then it'd be f of negative b over 2a. So it is up to you on which way you would like to do it. but either one would work. And I'll show you both ways. They're not much different. And then the last thing you want to do is find the y-intercept, which is setting the x equal to 0 or finding f of 0. All right, so the first one we're going to look at is this equation right here. F of x equals 5 minus 4x squared minus 5 minus 4x minus x squared. And again, our goal is that we're going to be able to graph it. So the first thing we want to do is rewrite it so it looks like it's in standard form. Remember, standard form is where we have the x squared first, then the x, and the constant. So I'd have negative x squared would come first, minus 4x plus 5. So that means this parabola would open which way? Down. Yep, there's a negative in front of the x squared, so this is going to open down. Then we can find our x-intercepts. So remember, to find the x-intercept, we set the f of x or the y equal to 0. So I'm going to have 0 equals negative x squared minus 4x plus 5. For us to factor this, which we're going to need to factor it because it's x squares and x's, we first have to do what? What kind of numbers in front of that x squared? Josh? Right. So we're going to have to pull out a GCF of negative 1 first, and then we can SAM factor it after that. So I'll have a negative in front, and then that just changes all my signs. Okay, then we can SAM factor that. So we would be saying what multiplies to negative 5 and adds to positive 4. So that would be positive 5, negative 1. And then when we set those factors equal to 0, the negative just crosses out or cancels out. And we will get negative 5 and positive 1. So our x-intercepts, negative 5, 0, and 1, 0. So if you haven't already, make an xy axis on your paper, and we're going to plot those two x-intercepts. All right, then we're going to find our vertex. So remember, to find the vertex, we can either find the average of the x values, average of the x-intercepts. So anytime you find an average, you add the two up. So I'd have negative 5 plus 1 divided by 2. I see. All right, so negative 5 plus 1 divided by 2 would be negative 4 divided by 2. So negative 2. So that means our h value is negative 2. That would also essentially be our axis of symmetry. So I can draw a vertical dotted line going through x equals negative 2. Now, if you chose to do the other way, I said the other way was doing negative b over 2a, you can do that. So our b is negative 4, so be negative negative 4 or positive 4 over 2, and a is -1. And notice you're going to get the same thing, -4 over -2, which is -2. So we get the same h value no matter which way you do it. So you decide whichever way you like better. But we still need our k value. Okay, so we know h is -2. We're going to need our k. So all we need to do is, this is an x value. If we know an x, to get the y, we just plug it in for x. So I'm finding now f of -2. So -2 is just going in for all my x's there. So it'd be -2 squared minus 4 times -2 plus 5. I do need to be careful here. I'd square -2 first, which is +4 times the -1, so it'd be -4 plus 8 plus 5. So that would give us 9. So -2 comma 9 is our vertex. So we can go ahead and plot that now. That's another point. So -2 right on that axis of symmetry like we expected, and up 9. All right, last thing we're going to do is find our y-intercept. So that is where we're going to plug 0 in for our x, or find f of 0. So that would be doing -0 squared minus 4 times 0 plus 5. So the first term becomes 0, the second term becomes 0, and we're just left with the 5. 0, 5 is our y-intercept. Yeah, well, anything without an x is, yep. All right, and the reason why we draw that line of symmetry there is because if you notice, there needs to be the mirror image on the other side. So this point is up 5 and 2 units away from the line of symmetry. So if I'm up 5, I can be 2 units to the left of the line of symmetry, and I have another point there. And then it's opening down like we expected it to. So it's definitely a little bit more work. This is one way you can do it, and then tomorrow we'll go over another way that maybe you'll like better, just different. All right, we'll do one more, and then you'll have some time to work. All right, so go ahead. We're going to try f of x equals x squared minus 2x minus 15. And you can take a moment, answer how does it open, what are the x-intercepts, and what's the y-intercept. All right, so how will this one open? It's going to open up. There's a positive in front. To get our x-intercepts, again, we're putting 0 in for the f of x, and we'd have to factor. There's no GCF, so we can just start Sam factoring right away. So what multiplies the -15 adds the -2. What? -5, +3. Good. And when we set those equal to 0, we get +5 and -3. So 5, 0, -3, 0, those are our x-intercepts. If you have not done so already, take a moment and make an xy axis, and we'll plot those points on there. And then the y-intercept, if you did that one already, again, that's just putting 0 in for the x's. So that gives us 0, -15. Now I would have to rescale my axes here. So I'm just going to cross these off. And I'm just going to say every 2 blocks, sorry, every 1 block is 2 now. So I'm going to just label that first one as 2. And then this first one is -2. Okay, so I'm going by 2 on my y-axis just so you don't get confused. And so 0, -15 would be 2, 4, 6, 8, 10, 12, 14, 15. So right there. All right, so we have those intercepts plotted. Now we want to find our vertex. Do whatever way you like better. If you like doing the -b/2a, do it that way. Okay, just check my answer. I'm going to do the average of the x-intercepts. And so I'm going to add 5 and -3 together. 5 plus a -3, and divide that by 2. So that would give us 2 divided by 2, which is 1. So the x-intercept average is 1, which again, that's going to be the x value for our vertex. And that would essentially be our axis of symmetry. So I'm going to draw a vertical dotted line going right through +1. I still need the y value for that, so I can just plug 1 into our original equation to find that. So if I do f of 1, that would be 1 squared minus 2 times 1 minus 15. Or 1 minus 2 minus 15. So that would be -1 minus 15, -16. So 1, -16 would be our vertex. So I would be right on the line of symmetry. 1, -16 is, again, I'm going by 2's. So it'll be at that block right there. Again, the reason why we have that line of symmetry drawn is because if you look here, this is 1 unit away from the line of symmetry, so I can go the mirror image point on the other side. So that gives me 5 points. And then we just do our best to make it look like a parabola. All right, once you have that, we're going to start the homework. So I'll put that up in a moment. All right, so the homework is page 360, numbers 5 to 8, 27, 29, 31. So for 5 to 8, these are 4 equations, and each equation matches with one of the graphs. Okay, so there are a couple ways that you could think about how this works, but there is no, you can't go off of where the vertex is because they're in standard form. So think about other ways that you could match the graph with the equation. All right, and you have the rest up here to work on that.